Hi everybody, welcome to the parametric and polar review. So the first thing that we're going to do is sketch the graph of r equals half cosine of 3 theta. When I made this table, I just wasn't paying very much attention. So 3 theta, and then we're going to do cosine of 3 theta, and then we're going to do half cosine of 3 theta. Okay, so when you're evaluating, we are working from the inside out. So we're doing this part first, then we'll do cosine, then we'll do the half. So first thing is to triple our angle. That's what this means. 3 theta, we're going to triple the angle. So tripling 0 is still 0. Tripling pi over 6 becomes 3 pi over 6. And 3 over 6 reduces to 1/2. Pi over 3 tripled. 3 divided by 3 is 1, so that's just pi. Pi over 2 tripled is going to work a little bit differently because 3 and 2 do not share a common factor, so we have to just leave that as 3 pi over 2. Then 2 pi over 3 times 3. Again, your 3's are going to cancel. 3 divided by 3 is 1, so we're just left with 2 pi. And this one's super fun. 5 pi over 6 times 3. Oops. So, like we said before, 3 divided by 6 reduces to 1/2. So we have 5 pi over 2. And then tripling pi would just be 3 pi. Now here's where we go to our unit circle. We're looking for cosine. We're looking for the x value. So we go to the angle 0, right here, and we look at our x value. We go to pi over 2, that's right up here. We look at the x value. We go to pi, it's over here. We look at the x value. 3 pi over 2, right down here, x value. 2 pi, back here to 0, x value. Now 5 pi over 2 is not something that's on our unit circle, so we have to subtract 2 pi. Getting a common denominator just ends up being the same spot as pi over 2. So again, that x value is 0, and then 3 pi, we subtract 2 pi, we just get pi back over here, and our x value is -1. Last thing to do is divide all of these in half. And I was a silly person and I did not give you a graph for this one. So I'm just going to move my unit circle. I'm going to do my graph over here. Now one thing I did say accurately on this one is that it is a 3-petaled rose curve, but we did enough that you actually don't need to repeat. You're actually going to get everything that you need right from this table that we made. So when we have a polar graph, it's not like our regular x and y coordinate plane like we're used to. This doesn't mean like go to 0 and go up 1. It doesn't mean left and right and up and down anymore. When we have a polar graph, we have these concentric circles, and these represent radii. So same angles as our unit circle. So we usually see like a line there, and a line there, line there, line there, dividing these up into thirds. You'll see on the next one a little bit better. Okay, so at angle 0, which is here, we have a radius of 1/2. At angle pi over 6, which is the first line, we have a radius of 0. At pi over 3, which is this second line, I'm -1/2. So I have to go backwards a half. At pi over 2, which is straight up, I'm at 0 again. So what I've done is I've come down, around, and back. And here's where that curve comes in. Then 2 pi over 3 right up here. and that's at a half again. 5 pi over 6 is back to 0. So I come up, I come back to 0. And then pi is negative half. So pi is straight out here. So going negative half is going back half. And there, it finishes off my 3-petal rose curve. All right, let's get down to one where we actually have the graph and everything. Okay, so I'm going to use my unit circle, and then I'm going to graph it on the polar. See how this has concentric circles going out? Those represent the radius that we're going to graph, and that's what this R equals. R is a function. Well, it's not really a function, it's an equation because these kind of repeat vertically. It's not really the same thing as an X and a Y coordinate plane. But R is our dependent variable and theta is our independent variable. So we're plugging in thetas, we get out R's. All right. So kind of starting off with the same kind of thing, except this time it's sine, and we don't have to do anything to the angle. We're going to take the sine of the angle, which is the y value. Then we're going to multiply by 4. Then we're going to subtract 1. And I picked some different angles this time. I picked some fourths. And if you notice on my polar graph, I don't have the fourths marked. They will be right in here. This would be pi over 4. And you can see this straight from the unit circle. It's kind of the same thing. Here, this is your 3 pi over 4. Down here is your 5 pi over 4. And here is your 7 pi over 4. So we're going to need the 5 pi over 4 and the 7 pi over 4, definitely. Okay, so sine of the angle is the y value. So go to 0, it's right here. What's the y? Go to pi over 6, what's the y? Go to pi over 2, what's the y? 2 pi over 3, pi. 5 pi over 4, 3 pi over 2, 7 pi over 4, and back to 2 pi. Now I'm going to multiply everything by 4. 0 times 4, half of 4, 1 times 4. Now these parts get a little tricky. So square root of 3 over 2 times 4. 4 divided by 2 is 2. Kind of the same thing over here. We have 4 times negative square root of 2 over 2. 4 divided by 2 is 2 again. All right. Now all we're going to do here is subtract 1. That's what this last part says to do. So we're going to minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. I'm going to need a calculator for the other ones. All right, so 2 square root of 3 minus 1 is approximately 2.46. And negative 2 square root of 2 minus 1 is about negative 3.8. All right. Now again, just like the last one, we're only graphing this top part, this top row, and this bottom row. That's it. This stuff was all of our work kind of in between. All right, so at angle 0, I'm at negative 1. So angle 0, that's here. Negative 1, I've got to go back 1. Pi over 6, I'm at positive 1. Pi over 2, 3. 1, 2, 3. So I've got that kind of curve going on so far. 2 pi over 3, I'm at 2.46. It's here. And then pi, I'm at negative 1, so back 1. So kind of have this little loop going on so far. 5 pi over 4 is here, but I'm at negative 3.8. 1, 2, 3.8, like there. I gotta come up. 3 pi over 2, I'm at negative 5. 3 pi over 2 is here, but I'm going negative 5. So other way, 1, 2, 3, 4, 5. 7 pi over 4 is down here, but I'm negative 3.8 again. 1, 2, 3.8. And then 2 pi, which is here, I'm at negative 1. Already been there. There's my little loop-de-loop. All right, what else do we have here? Give 2 representations of each polar coordinate. All right, I'm actually going to do 4, but on the test, I'm only going to ask you for 2, but I'll show you all 4 here. So A, let's start off with the easy one. So what row or what circle am I at? 1, 2, 3, 4. What angle? Pi over 3. Now I can also do this using a negative angle. So positive pi over 3 goes that way. So I'm asking you how much around and there. So if I subtract 2 pi from this, I get negative 5 pi over 3. So another way to do it. Now I can also do this using a negative radius, which means what angle would I have to be at to go backwards 4 to get to A? Well, forwards 4 is this way. So backwards 4 is that way. So what angle is this? 5 pi over 4. Now that's a positive 5 pi over 4. That means going this way, I would land at 5 pi over 4. So what about going this way? Whoops, I just switch colors. What about going this way? How much is that negatively? Well, if I take 5 pi over 4 and I subtract 2 pi, that's negative 3 pi over 4. So there's positive, 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 negative, negative, positive, negative, negative. 4 ways to do it. All right, let's look at B. B's right here. So the easy one is it's on the 1, 2, 3rd circle, and it's at the angle 11 pi over 6. Well, that's positive 11 pi over 6. That means go all the way around here and you land there. Well, negatively, if I just go like that, I'd be in the same spot. So what's 11 pi over 6 minus 2 pi? That's negative pi over 6. Now I can also do it with the negative radius. So what's directly across from this? This is 3 forwards, so what's 3 backwards? What's directly across from 11 pi over 6? 5 pi over 6. Now that's positive 5 pi over 6, which is also negative what? So what's 5 pi over 6 minus 2 pi? Negative 7 pi over 6. Positive, 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 negative, negative, positive, negative, negative. 4 options. Oh, I only have a minute left in this video. Okay, so let's do C real quick. So the obvious answer for C is 1, 2, 3, 4, 5, and 3 pi over 2. That's also 5 and negative pi over 2. That's also negative 5 and positive pi over 2. So going backwards. So this is positive pi over 2, which would be negative 3 pi over 2. All right, check for the rest in the next video.